Good morning, dear friends. It's my pleasure to welcome all of you once again for these VLC sessions. Dear friends, in engineering, drawing is called as the language of engineering. So, today we have with us a very special guest, Professor R.M. Nafde sir, Government Polytechnic, Jalgaon. Dear friends, he has a wide experience in this field. He has conducted a number of trainings in this field, and he is the real guide for all of us. So, without taking much of your time, I welcome him and I request him to continue with the lecture. Good morning, sir.
Thank you, sir. Good morning, friends. As I said in introduction of myself, that engineering drawing is a language of engineers, and it is very necessary to all the engineers like you, becoming engineers, that you must know the details of engineering drawing in depth. That's why this course is kept in your curriculum in each semester. Like in first semester, you are studying engineering graphics. In second semester, engineering drawing, like that, and machine drawing. So here, in this subject, engineering drawing, we will see now today the lecture on the projection of solids in first session, and in second session on section of solid. Before going to in details of projection of solid, the prerequisites for this session is necessary, and these are nothing but the projections. What do you mean by projections and the different methods of projections? So before going to in detail, let us have a look on this prerequisites, and then we'll go to in details. Now the objectives of this session are, at the end of this session, you must be able to define the solid, what is meant by solid, then know the different types of solids. You must know the terminology used in solids, means what are the different nomenclature of the solids. Then understand the procedure of drawing projection of solids, how the projection of solid is drawn. Then visualize and draw the projection of regular solids on horizontal plane and vertical plane. Now, what do you mean by solid? First, solid may be defined as a three-dimensional object having length, breadth, and height, bounded by surfaces with which may be plane or curved or combination of two. We know that the first topic of our syllabus is the projection of lines and projection of planes. Lines have the 2 points. Then if we add the third dimension, then it becomes a plane. Sorry, no, second dimension, it becomes a plane. That plane have the negligible thickness, but have the length and breadth. And if we add a third dimension to that, in addition to length and breadth, we will get the solid. That is, a third dimension is a height. So this is the solid, means a three-dimensional part, and which is bounded by the surfaces which may be plane or a curved, like, or what may be the case. Like in case of prisms, it is in a plane form. If in case of cylinder, it is in a curved form, like that. And to draw the complete representation of a solid on principal plane, at least two views are necessary, that is front view and top view. Means at least two views are necessary to understand what type of solid is given in the problem. Okay, so we will see in depth, in detail, step by step again. Okay, so but before that, let us we go on the blackboard to explain the, or to just recall the prerequisites required for this subject, the which we have studied in the last semester. That methods we have studied in the last semester, that is what do you mean by projection, what are the different methods of drawing the projection, that is first angle method, third angle method, like that. Now in our curriculum, only first angle method is included, so we will majorly concentrate only on first angle method. So let us go on the blackboard and see. We will see, just in short, we will just recall the previous knowledge. That is a, now see, basically what is there? There are the four quadrants, as we know. there are four quadrants basically. These are the planes. This is the horizontal plane and this is the vertical plane. And it is assumed that these planes are the transparent planes. Okay. So this is the first quadrant. This is second quadrant. And this one is the third quadrant and this one is the fourth quadrant. Okay. Now what happens? According to the BIS code, Bureau of Indian Standards, which are revised in 1988. So according to this code, we have to turn this horizontal plane in 90 degrees like this, in clockwise direction this way. So when you open this two horizontal plane in clockwise direction, you will see that the first quadrant will get open and third quadrant will get open, while the second quadrant and fourth quadrant automatically will get closed on. Okay, that's why we only consider the first angle method and third angle method, and we are not considering the second and fourth angle method. Okay, now what happens now? In first angle method, here just look here. If we keep an object here, for example, if it is an object, okay, if it is an object, so here is the position of the observer, which is the fixed position. This is the who is the observer. Okay, when you observe this object exactly at perpendicular direction to the surface of the object, your iris passes over the contours of this particular object like this. Your iris passes over the contours of the object, and this iris comes on the back side, and you will get an image on this vertical plane here. You will get the image on this vertical plane here. So you will get the picture or the image of the object which you can see from the front direction here. This image you can see here. Okay, so these iris are called the projectors. These iris are called the projectors, and the image which you get here on the plane, that is called the projection. Right, you have already gone through this, but just recall, I am calling it again back. Okay, this image form, it is a projection, and these iris are nothing but the projectors. Okay, now similarly, when you observe it from the topward direction, okay, you will get the view on horizontal plane here. This is the view. Okay, this view is also called the projection, and these are the projectors. Now this view which you get on the vertical plane, which is observed from the front direction, it is called the front view, and this view which you observe from the topward direction, this is called top view. Now when you rotate the horizontal plane in clockwise direction in 90 degree, you just observe here what happens. If this is a joining line, or it is called the reference line, which joins the two planes, this is the joining line. Here is the, we draw here the joining line, just call it as a XY line. Okay, and above the XY line, which plane is here above the XY line? Above the XY line, this is a vertical plane. So above the XY line, there is a vertical plane, and below the XY line, when you turn this horizontal plane in 90 degree, okay, so below the XY line, you will get horizontal plane. Okay, now on the vertical plane, which view will get here? Observing from the front direction, it is a front view. So above the XY line on vertical plane, you will get here front view. Okay, and exactly below that, you just see, when you turn this horizontal plane through 90 degree in the clockwise direction, this top view will come in the downward direction. So just exactly below this, here you will get a top view. Okay, here you will get a top view, front view and top view. Now what is the principle of the first quadrant? Now you see here, this is the observer, then this is the object, and this is the plane. Observer, object, plane. The principle is observer, object, and plane. Right, the principle of the first quadrant is observer, object, plane. Similarly, on the back side or top side, observer, object, plane. Okay, so this is the principle of the first quadrant. Now to get the side view, what we want again? We want the observer, object, and plane. So let us assume that here we have attached one principal plane again here on this side. On this side, suppose we attach one principal plane on this side, and observing this project from the side direction. So this is the, suppose left hand side, you are observing it on the left hand side. So when you observe from the left hand side, you will get the projection on the back side, okay, in this way, observing from the left hand side, okay. And when you turn this quadrant in the back side, you will see that on the front view, you will side, on this side there is a left hand side view, and here on this side there is a right hand side view, okay, on the back side, because the principle is observer, object and plane, okay. So considering this basic, now we will proceed for the section of solid. What is given in the section of solid that we have to study proceeding this particular object. So let us see again back, section of solid, what is given in this section of solid. So solid may be defined as a three-dimensional object having length, breadth and height, bounded by a surface which may be plane or curved or combination of two, okay. Now these are the different types of solids. So two solids are shown here, just go through it carefully. First solid is a called tetrahedron, and second one is a cube, okay, tetrahedron and cube. Now what is tetrahedron? Tetrahedron, all faces are equilateral triangle. It is a solid which formed by the four equilateral triangles. At the base there is a one equilateral triangle C, A, B, C, and on the three sides you can see the three equilateral triangles, that is A, C, O, O, C, B and B, A, B, O, like that. Now this is had a center exactly at the center. This is the center point at the base, and O to S is a center, it is called axis. Then these are the triangular faces, all edges are equal, okay. These are formed by the equilateral, four equilateral triangles together form a tetrahedron. Now go for the cube. Now what is cube? 1, 2, 3, 4, 5 and 2 bases, 6 faces, okay. Exactly square, 6 faces. This is exactly center, this is the axis. Then these are called the edges. What are they? These 3 to C, 2 to B, 8 to 1 and 4 to D. These are the edges. Then these are the faces, okay. 1, 2, 3, 4, 5 and like that, 6 faces, okay. So cube is a solid having 6 faces, exactly squares, and triangle is a solid having the 4 equilateral triangles together, okay. Next solid, prisms. This is a triangular prism. The base of this is a triangle. It may be a equilateral triangle, it may be isosceles triangle. Then pentagonal prism. The base and the top both are exactly same. Then square prism. It is nothing but a, you can say the cube also. Then hexagonal prism. The base and the top both are exactly similar. See, there is a hexagon and at the bottom also there is a hexagon. So the prism is, what is the specialty of the prism? You can see the, in all types of 4 types you can see that the base and the top both are exactly similar. In first case here, see, the base is a equilateral triangle but top is a point, okay. Now in this case all the base and top both are the exactly similar, and these corners are joined by these edges that are called the longer edge, shorter edge, like that, base edge, okay. So let us go for one by one. Here is a top face of the triangular prism, then is a top edge. These are the top corners, 1, 2, 3, okay. Now at the bottom this is a base corner, this is a base edge, and these are the 3 corners A, B, C, and this is the axis, okay. Now this is called the rectangular face because it is a plane surface. Just we have seen in definition. What is that? It is a length, height and width, okay, and bounded by a plane surface or a curved surface. So it is bounded by a 1, 2, 3 plane surface. Here 1, 2, 3, 4 surfaces. 1, 2, 3, 4, 6 surfaces. So bounded by a plane surfaces. That is all. And second thing, in all types of prisms, generally the faces are rectangles. Exactly rectangles. See here. This is a rectangle, this is a rectangle, this is a rectangle, and this is also a rectangle if it is a rectangular prism. Now it is a square prism, so it is a 100% square. Okay. Now the next type is the pyramid. What is given in the pyramid? See, the difference in prism and pyramid, try to understand. In a prism, the base and top both are exactly similar. Base and top both are the exactly similar and joined by the rectangular faces. Now in pyramids, the base is a polygon. Base is a polygon, and all the triangular faces comes together and join in this particular point at the top point called the apex point. ओके, म्हणजे पिरॅमिडला असा हा वरती एक निमुळता पॉईंट आलेला असतो, याला म्हणायचं अपेक्स, आणि त्याचा बेस कसा पॉलिगॉन. कुठलाही पॉलिगॉन, इथे ट्रायंगुलर, स्क्वेअर, पेंटागॉनल, हेक्सागॉनल, इट मे बी एनी टाइप. Okay, so base may be different, but all the triangular faces comes in join together at the top, that is called the apex point. See here, this is a triangular prism pyramid. Apex, this is the axis, then base corner, base edge, and this edge is called a slant edge, joining three sides, slant edge, and this is a slant face. Okay, now here see, this is the slant edge and this is a slant face. So how many faces is here? 1, 2, 3, and backside 4. Okay, and this is a base, because it is square pyramid, so these are the 4 faces. This is a triangular pyramid, these are 3 faces. Okay, here are the 5 faces. And one thing you have to observe here, one thing is that in all types of pyramids, the faces are exactly equilateral triangles, while in case of prism, the faces are rectangular. See, this is a rectangle, this is a rectangle, okay, a rectangle. While in case of pyramid, all the faces are triangular, equilateral triangles. Sorry, isosceles triangle. Okay, this is the main difference between the pyramid and prism. What I found that the students always get confused while in the problem the prism is asked and they draw the pyramid, or pyramid is asked and they draw the prism. So don't get it confused and try to clear the conceptual concept that the prisms are the top and base are exactly similar, and pyramid is the at the base there is a polygonal base and all the points come together and join in a point, that is called the apex. So only pyramid have a apex point, prism does not have the apex. See, prism does not have the apex, only pyramid have the apex. Okay, next. Now these are the different solids, that is a curved surface. The solids having the length, width, and height and joined by the curved surfaces. Okay, initially these are the plane surfaces. See, this is a triangular but it is a plane surface. In this case, this is a rectangular face but it is a plane surface. So rectangle, triangle, and here is a curved surface, cylinder, curved surface, cylinder, curved surface. It is a cone but it is a curved surface. Okay. Now this is cylinder. What are the terminologies cylinders use? Now at the base and top both are the exactly shape, cylinder, cylinder, like in case of prism. If we compare with the prism, in prism also the base and top is a similar face, it is a polygon, polygon. In cylinder also same base and face is the same shape, but the difference is, what is the difference? These all surfaces are joined with the help of the imaginary lines, that is called the generators. You can't see this generator. In actual practice, these generators are not visible. These are the imaginary lines. Number of imaginary lines, indefinitely. Number of imaginary lines are there, and these are called generators. While in case of prism, you can see these lines. In practice also, you can see these lines, and these are nothing but the longer edges or the slant edges. Okay. So try to clear the difference between prism and cylinder again. What is that? Sorry. In cylinder, base and top is exactly similar, like in a pyramid. Okay, but in like in a prism, base and top exactly same, but these are joined with the help of a curved surface having a number of imaginary lines, that is called generators. And in prism, the top and base, or base and top, is exactly similar and joined by the plane surfaces, and these lines are visible in practice. These are called the longer lines, and these are visible in practice. But both solids have the axis. This is also have axis, and prism also having axis. This is called the